Episode 26, AI System Design Interviews, the STAR Framework for Senior AI Engineers. Welcome back to Agentic AI World's Interview Prep Series. I'm your host, and today we're tackling something that trips up even seasoned engineers: how to structure your answers in AI system design interviews using the STAR Framework, adapted specifically for AI systems. Let's get right into it. Part 1. Why AI system design interviews are different. Traditional system design asks you to design a URL shortener or a Twitter feed. AI system design interviews go deeper. They test your ability to navigate uncertainty, make model trade-offs, and think about the full MLOps lifecycle. Interviewers at top companies like Google DeepMind, OpenAI, Meta AI, and Anthropic are not just testing if you know what a transformer is. They want to know, can you break down ambiguity into concrete decisions? Can you articulate why you chose one approach over another? Do you understand the production realities of AI systems? That's where the STAR framework comes in, but not the usual STAR you know from behavioral interviews. Part 2. The AI STAR framework. Here's the adapted version for AI system design. S. Scope the problem. T. Trade-offs and technology choices. Architecture walkthrough. R. Reliability, monitoring, and iteration. Let's break each one down. S. Scope the problem. Before drawing any boxes, ask clarifying questions. This is not just a courtesy. It's a signal that you think like a senior engineer. Great scoping questions for AI. What's the scale? 1 million requests per day or 1 billion? What's the latency budget? Under 100 milliseconds? Under 1 second? What data do we have? Is it labeled? How fresh is it? What's the acceptable error rate? A wrong medical diagnosis versus a wrong product recommendation are very different. Is this real-time inference or batch processing? A common mistake: jumping straight to "we'll use a transformer model" without establishing what success looks like. Pro tip: define your success metric first. Precision, recall, F1, NDCG. Pick the one that maps to the business problem, then design towards it. T. Trade-offs and technology choices. This is where most candidates either shine or fall apart. Interviewers want to hear you reason, not recite. Key trade-offs to discuss. Trade-off 1. Model complexity versus latency. A 70 billion parameter LLM gives better quality but costs 10x more per inference than a 7 billion parameter model with fine-tuning. When would you choose each? If the task is narrow and well-defined, say, classifying customer support tickets into 20 categories, a fine-tuned small model wins every time. Trade-off 2. Build versus buy. Should you host your own open-source model or call the OpenAI API? Considerations: data privacy, cost at scale, customization needs, and latency. For a regulated industry like banking or healthcare, self-hosting wins on compliance. For a startup with low volume, the API wins on speed to market. Trade-off 3. Online versus offline feature computation. Real-time features give freshness, but add latency and complexity. Pre-computed features are fast, but can be stale. A recommendation system for e-commerce might use pre-computed embeddings for products, but real-time user context for session activity. Trade-off 4. RAG versus fine-tuning versus prompt engineering. Here's a quick mental model. Prompt engineering: fastest, cheapest, but limited by context window and model knowledge. RAG: great when knowledge changes frequently or is too large for context. Fine-tuning: best when you need consistent style, tone, or domain-specific reasoning baked in. In production, you often combine all three. Architecture walkthrough. Now you draw the boxes. Walk through your architecture clearly, layer by layer. For an AI system, a solid architecture walkthrough covers: 1. Data ingestion layer. Where does data come from? Streaming, Kafka, Kinesis, or batch, S3, BigQuery? How is it validated and cleaned? 2. Feature engineering layer. What features matter? How are they computed and stored? Do you need a feature store? Tools like Feast, Tekton, or Vertex AI Feature Store help here. 3. Model layer. What model architecture? How is it trained? Where are the model artifacts stored? MLflow, weights and biases, Vertex AI Model Registry. 4. Serving layer. How does the model receive requests? REST API via Fast API? gRPC for lower latency? Model server like Triton Inference Server or TorchServe? Do you need model caching? Batching. 5. Post-processing and guardrails. For LLMs specifically, are you running output filters, toxicity classifiers, PI redaction? This layer is critical for production safety. 6. Feedback loop. How do you collect ground truth? How do you detect drift? How do you trigger retraining? This is where most junior candidates skip and senior candidates stand out. R. reliability, monitoring, and iteration. This is the section that separates 5-year engineers from 15-year engineers. Anyone can design a happy path. Senior engineers design for failure. Monitoring for AI systems has 3 layers. Layer 1, infrastructure monitoring. CPU, GPU utilization, memory, latency percentiles, P50, P95, P99, error rates. Use Datadog, Prometheus, Grafana. Layer 2, model performance monitoring. Is model accuracy degrading? Is the output distribution shifting? Track metrics like prediction confidence, class distribution, embedding drift. Layer 3, data drift monitoring. Are the input features drifting from what the model was trained on? Tools like Evidently AI, YLogs, and RI's AI specialize in this. For reliability, circuit breakers. If your model is down or too slow, fall back to a simpler rule-based system rather than failing the user. Shadow mode deploy. Mint. Run your new model in parallel with the old one, compare outputs, before switching traffic. Canary releases. Send 5% of traffic to the new model, monitor metrics, then gradually roll out. And for iteration, the best AI systems are never done. You need a feedback loop. User signals label quality, retraining pipeline evaluation deployment. This cycle should be automated and tracked. Part 3. Putting it all together, a live example. Let's apply AI Star to a real interview question. Design an AI content moderation system for a social media platform. Scope. 100 million posts per day across text, images, and video. Must flag harmful content within 5 seconds of posting. Target. Less than 1% false positive rate, wrongly removing benign content. Less than 5% false negative rate, missing harmful content. Regulatory requirement. Human review queue for appeals. Tradeoffs. We'll use a multimodal approach, separate models for text, image, and video, with a fusion layer. For text, a fine-tuned BERT-class model beats GPT-4 on cost and latency for classification tasks. For images, a vision classifier, VIT or ResNet-based, trained on our labeled data. Video, sample keyframes every 2 seconds, run image classifier, plus audio transcription for audio-based violations. Architecture. Posts ingested via Kafka Stream. Text, image, and video sent to parallel classifiers via async microservices. Results aggregated by a fusion model that outputs a risk score. Posts above threshold, 0.8. Auto-removed. Posts in gray zone, 0.5 to 0.8. Routed to human review queue. Escalation tier. Severe violations trigger immediate action and law enforcement pipeline. Reliability. Shadow mode for new models before promotion. Monitor false positive rate weekly by sampling auto-removed content for human spot check. Retrain quarterly on newly labeled data from the human review queue. Circuit breaker. If classifier service is down, posts are held in a quarantine buffer, not published, preventing abuse during downtime. Closing. That's AI Star in action. Let me recap. Scope before you design. Ask the right questions. Articulate trade-offs. Show you can reason, not just recite. Walk through your architecture systematically. Design for failure. Monitor everything. Plan for iteration. The engineers who get hired at top AI companies aren't necessarily the ones with the most knowledge. They're the ones who think clearly under pressure and communicate their reasoning well. Use this framework in your next mock interview. Time yourself. Practice saying your trade-offs out loud. It gets easier every time. That's all for episode 26. If you found this useful, drop a comment below with the AI topic you want covered next. Subscribe to Agentic AI World for daily interview prep. We publish every single day. See you tomorrow.